Okay, so we're going to practice writing our trig functions in terms of sine and cosine, but not just for the sake of doing it, but for the sake of simplifying expressions and proving trig identities. So let's do our first example here. Let's say I want to simplify the following expression: cosine of t times cosecant of t. And so in this case, there's not a whole lot we could do, but we could certainly rewrite cosecant of t in terms of sine and cosine. And we know that cosecant of t is 1 over the sine of t. It's the reciprocal of the sine function. And now all that's left is to multiply these together. And so to do that, you need to think of cosine of t as a fraction by putting it over 1. And then you simply multiply the numerators and the denominators. And so on top you get the cosine of t, and on the bottom you just get the sine of t. Now this should look familiar as well. This is the reciprocal of sine of t over cosine of t. Sine of t over cosine of t is tangent, which means that the reciprocal of that will be cotangent, and of course of t. So cosine of t over sine of t is the same thing as cotangent of t. And that's about as simple as you can get here. So we've simplified the expression. Let's try another one. Let's say I want to multiply tangent of theta times cosecant of theta. Well, tangent of theta is sine theta over cosine theta times cosecant of theta is the reciprocal of sine, so it's 1 over the sine of theta. And when I multiply straight across, I'll get a sine on top and a sine on bottom that cancels, leaving behind 1 over the cosine of theta. That's the reciprocal of cosine, which in other words is the same thing as the secant of theta. And that's as simple as that one gets. Let's do another simplify problem. Let's say I've got secant of beta over cosecant of beta. Well, secant of beta is 1 over cosine of beta, and that's all over, so I'll make a larger fraction bar here. Maybe I'll lower my equal sign there. So secant of beta is 1 over cosine of beta, and that's all divided by cosecant of beta, which is the same thing as 1 over sine of beta. Notice that my big fraction bar here separates the yellow fraction divided by the green fraction. That's important to understand what order your division is taking place. Now to do this division, I have to multiply the top fraction by the reciprocal of the bottom fraction, meaning I've got to flip the bottom fraction and make it times. So it's going to be times sine of beta over 1. And now when I multiply straight across, on top I get sine of beta, and on bottom I get the cosine of beta. And sine beta over cosine beta is the same thing as tangent of beta. Okay? So there are several examples of simplifying trig functions simply by rewriting them in terms of sine and cosine, and then doing some basic algebra with fractions. All right, let's try our first hand at a proof. So the first thing we want to try to prove maybe is that tangent of x over secant of x equals sine of x. And so what we're going to do is kind of separate this into a left-hand side and a right-hand side. Well, the right-hand side is sine of x. I can't really do much with that, so I'll do all of my work on the left-hand side. So the left-hand side is tangent of x over secant of x. So that's sine x over cosine x all over, I was put my equal sign in the wrong spot there when I've got a complex fraction. So tangent x is sine x over cosine x divided by secant of x, which is the same thing as 1 over cosine of x. Now, You can do some cancellation as it sits here. For example, you could cancel the cosines in this particular case, but sometimes you can get into trouble when you try to do that. So you may be better off for a while rewriting it as sine x over cosine x times the reciprocal of the bottom, cosine x over 1. And then if you multiply straight across, you'd have a cosine on top and a cosine on bottom that would cancel, just giving you sine of x. And so what we've got is the left-hand side. We started with the left-hand side, and that equals the sine of x, but the sine of x is the right-hand side. So to conclude our proof, we'll go ahead and say, well, that equals the right-hand side. And so now what we've done is we've proven that the left-hand side, through a series of equalities, the left-hand side equals the right-hand side. And that's the end of our proof. So we'll indicate that by shading in the end of proof rectangle. Okay? So that's a simple little proof there, rewriting the functions in terms of sine and cosine. Let's try another one. Let's try to prove that cotangent x times secant of x over cosecant of x. Let's try to prove that that equals 1. Okay? So again, this time we can't manipulate the right-hand side much because 1's about as simple as it gets. So we'll start with the left-hand side and see if we can turn it into 1. Okay? So the left-hand side equals. So cotangent of x is cosine x over sine x. And that's multiplied by secant of x, which is 1 over cosine of x. And that's all divided by cosecant of x, which is 1 over sine of x. Okay? Now let's clean this up methodically. One good thing about proofs is that you always know what you're trying to get as your answer. That's also the bad thing about proofs, because when you know the answer, you might just force what you've got to turn into the answer and not do it correctly. So let's be very methodical here. Let's multiply what's on top. Okay, let's do that first. When I do that, I'll multiply straight across. So I'll get cosine of x, and on bottom I'll have sine x cosine x. That allows me to cancel my cosines. So now what I have on top is 1 over the sine of x. And that whole thing is over this fraction, 1 over sine of x. Well, now we know that whenever we take something, such as 1 over sine of x, and divide it by itself, that always equals 1. And that's what we needed here to show that it equals the right-hand side. So we'll finish our proof by saying, well, that equals the right-hand side. And we've proven then that the left-hand side and the right-hand side are, in fact, equal. And so that's the end of our proof. And so there are several examples of how to use the trig functions to simplify or to prove identities by rewriting them just in terms of sine and cosine.